In the last video, we made these two circuits here. The ROM circuit and the no ROM circuit. And I suppose, well, we better wire one up, haven't we? But first, I was thinking it would be really useful if the human man didn't have to move around a load of jumpers. Yeah, all them ones, human man. If there was a way, we could just do it using the computer. What we'd need is, some way to change all them inputs, wouldn't we? Let's say, I don't know, shift registers or something? Human man, you've already done it! But we still need a way to communicate between these shift registers and a computer. Well, I suppose we could use that Arduino. It's not actually an Arduino though. Nah, it's a cheapo one we got from AliExpress. And as you can see by how dirty it is, it's been kicking round for about 12 years. So, yeah. Let's build the circuit. So what the human man's going to do is take all the outputs of these shift registers and stick them on the inputs of our conveyor belt. Right, human man, let's test it. Right, so connect up the USB. For some reason, we have to disconnect it and reconnect it for the computer to recognise it. Don't know why, just something we have to do. Right, so I'll bung some numbers in there and we'll see what happens. Now, the human man is going to check just to make sure they've gone in there, using that LED there. Yep, so start from the left hand side and make your way across, human man. So, our first number is 5. So it should be 0, 0, 0, 0, 0, 1, 0, 1, which it is! Yay! The next one should be 0, 0, 0, 0, 0, 1, 0, 0. Yay! And then it should be 2. Oh no, human man, that one was 3. That one was 3, wasn't it? So yeah, that is right. Yeah, that's right, human man. This one's 2. Yeah, now the rest are zeros. There we go, human man. And this one's 128. Ooh. It's working, human man! Yay! Now I suppose you better fit the outbound buffer in ya. Yeah, that thing there, human man. You stick that on there. The outbound buffer is basically exactly the same as the conveyor belt, except that the source register is a 74HC245. So, there we go. The human man has connected the outputs of the conveyor belt to the outputs of the outbound buffer. And he's connected the inputs of the source outbound register to the address on the board. Now, the human man, he needs to add some more shift registers so we can read the outbound message. No, human man, put it on the other side. Yeah, see, that uses less wire, doesn't it? Might not look as good, but it's cheaper, so that's what we're gonna do. We'll come back when the human man has wired that lot up. Right, well, I suppose, seeing as the human man's done all that, we should probably test it. So go on, human man, you plug it in. And obviously you've got to plug it in again for some reason. We should probably figure out why, but, well, I can't be bothered. So, let's just put some numbers in. And so, when we give it another set of numbers, we should get out what we just put in. And look at that! It works! Yay! We don't really want to be using the serial monitor on the Arduino IDE for our whole lives, do we? What we should do is make a fancy GUI. Ooh! Right, well, I suppose we better open up the program, haven't we? Here we are, old Natter. And look at that! Isn't that fancy? We got a thing here to put the inbound message, and the outbound message who pops out here. We can have it in binary, decimal, or hexadecimal. And look, we made a couple of happy little macros over here. So we can load multiple messages, and we can parallel load a binary file. And down here we've got a super handy control register tool, so we can just put whatever we want in here, and then we can send it up here, so we don't have to sit around worrying about what's what. Right, so we better plug the Arduino in, haven't we, human man? Hang on a minute, we've changed Arduinos there. That's because the other one, well, it wouldn't connect properly. So we're using this one instead. Right, so human man, you better plug it in, ain't ya? See, look, it's all connected down there. So let's send a message. All ones. That's an exciting message to send, isn't it? And there you go. Now, as before, if we send it again, it'll pop out on the output. There you go. Now, let's try sticking a 0 in the destination box, because that's the address of this board. And look at that, the destination is equal to the address on this board. So look, in the outbound message we can change it to a decimal if we like, or a binary. We can get the output, whoa, get the input, well, it's the same as the output on that one. Let's put some more exciting numbers in there. Oh yeah, no, obviously you can't do that, can you? But really I knew that, I was just doing that to show off my error dialogue thing. Let's run the macro. Oh, well, the file only had 4 messages in it. What about the parallel load one? Whoa, look at all them go! Whoa! Yeah, let's stop that. That's going for ages. Look at that. It loaded 3,000 bytes. Well, I mean, I suppose that's that. Yeah, I sort of hyped that up a bit, didn't I? It's not really that exciting, is it? I think we'll leave that there for now. Because otherwise, this video's going to end up being super long. And it'll probably take us another 2 or 3 weeks to make it. So, I thought I'd put this out now. Because I know, I'm a bit slow at putting videos out. Next time, we'll be wiring up the decoder board. We might even stick the Z80 on there and run our first test program. That'll be exciting, won't it? So, yeah, bye. Roll, 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 bog! Let us watch as Jeff flies majestically in his portable toilet, propelled by nothing less than his own torrential diarrhea.